Hi, Assalamualaikum. Before we start presenting our findings for task 3, let me explain a little bit about memory forensics, which is the process of capturing and analyzing RAM from a running system to preserve valuable evidence before it disappears. By acquiring a memory dump, investigator can recover critical information that this forensics simply cannot provide. So why it is important? Because it reveals running process and active network connection. It also recovers encryption keys, password, and even plain text credential. Lastly, it detects malware, rootkits, and memory-only attacks.
Assalamualaikum, my name is Hadira Badisha and we are going to presenting our task 3, which is to analyze malware.vmem file which contains memory dump of a system that is infected with malware. The first task is to identify the system. To identify the system, you need to write the command prompt as administrator and change the directory to volatility master. And then we will use the default installation folder for Python 2.7 on Windows, which is Python 27 and python.exe, so that Windows run the following file using Python interpreter because volatility is written in Python and it's Python to execute. Then in the same command, we need to insert vol.py, which is volatility framework main script, to perform memory forensic. It will run using the program stored in the folder. Next, we will insert fmalware.vmem in the same command, which F stands for file. To test volatility, we are specifying a memory dump file, and malware.vmem is the name of the memory dump file to analyze. We also insert image info, which is used to identify the system. Enter to run the command and wait for the analysis to be completed. Based on the image info analysis, it shows the operating system version, service spec level, architecture, PAE or physical address extension status, and memory dump timestamp. This is critical because we must use the correct profile for all subsequent analyses so that the result will be reliable. Wrong profile will make unreliable result. The image info plugin identifies our system as Windows XP Service Pack 3 running on a 32-bit architecture with PAE enabled. This means we will use the WinXP SP3x86 profile for all our commands. The timestamp shows this time was captured back in July 2012, which is consistent with a Windows XP.
Assalamualaikum, my name is Darina Haifa. I will demonstrate the infected process analysis. The first command we use is pslist, which lists all active process running in the memory image. From the output, we identify explorer.exe with process ID 1484. Explorer.exe is normally a legitimate Windows process responsible for managing the Windows File Explorer. At this stage, nothing appeared unusual. However, this process was selected for further investigation because later analysis will show that it was communicating with suspicious external network connection. Next, we use the PS3 plugin to examine the parent-child relationship between process. The output shows that reader_sl.exe with PID 1640 was launched under explorer.exe. This confirms that explorer.exe was actively running and interacting with other processes. Process tree analysis is important because it helps investigators understand how process were created and whether there are any unusual process relationship that could indicate malicious activity. After that, we use the pscan command. Unlike pslist, which reads the active process list maintained by Windows, pscan scan memory directly for process objects. This makes it useful for detecting hidden or terminated process that malware may try to conceal. In our case, pscan also identified explorer.exe with PID 1484 and its result was consistent with pslist. This means explorer.exe was not a hidden process but was genuinely active in memory. Based on the combined results from pslist, ps3, and pscan, we can identify that explorer.exe as the process of interest. It was running from its normal location, see Windows Explorer.exe, which makes it appear legitimate. However, because it was associated with suspicious outbound network activity, we suspected that the process had been compromised through malware injection. To verify this, we use the malfind command. The purpose of malfind is to detect suspicious memory regions that may contain injected or hidden executable code. It searches for memory pages with permissions such as page execute read-write, where the memory can be read, modified, and executed. These permissions are uncommon in normal Windows process and are often associated with malware code injection. The results identified suspicious memory regions in both explorer.exe with PID 1484 and csrss.exe with PID 584. This strongly suggests that malware injected its code into this legitimate Windows process instead of creating a separate malicious process. By hiding inside trusted process such as explorer.exe and csrss.exe, the malware can blend in with normal system activity and reduce the chance of being detected by users or security software. To verify this, we use the malfind command. The purpose of malfind is to detect suspicious memory regions that may contain injected or hidden executable code. It searches for memory pages with permissions such as page execute read write, where the memory can be read, modified, and executed. These permissions are uncommon in normal Windows process and are often associated with malware code injection. The results identify suspicious memory regions in both Explorer.exe with PID
Next, we want to
1484.
identify malicious network connection. Using the same command with Python folder, volatility framework, and profile together with connection command. The output is the most critical finding. It shows that the connections plugin revealed an active outbound TCP connection from Explorer.exe or PID1484 to IP address on port 8080. Port 8080 is frequently abused by malware for command and control communication. This is highly suspicious as Explorer.exe has no legitimate reason to connect to external server. To prove that this is malicious, VirusTotal is used to confirm the IP address. It shows that the remote IP is located in South Africa, which is geographically unusual for a system in the US or Canada.
Okay, next I will explain the other characteristic of malware detection that we discovered during the memory analysis. We use several volatility plugins, which is the DLL list, CMD-line, and ConScan. For the DLL list, I use command Python exe in C drive volatility dash master, and then vol.py dash f malware.vmem dash profile equals win x psp 3x86 dll list dash p 1484. So this command lists all the dynamic link libraries loaded by Explorer.exe. From the output, we can observe that Explorer.exe loaded several important networking DLL, including Wininet.dll. These DLLs provide internet communication function, which means Explorer.exe had capability to communicate to external server. So since earlier analysis already shows suspicious network connection, these networking DLL support the conclusion that malware was using Explorer.exe to communicate over the internet. Okay, next I will show you the second command, which is I use the Python 27-python.exe in C drive volatility the volatility dash master dash vol.py dash f malware.vem dash profile win x at psp 3x86 cmd line. Enter. This plugin will show how each process was launched. Output means Explorer.exe was launched from Windows directory. At first glance, everything looked legitimate. However, we need to remember that earlier finding shows that this same process was communicating with suspicious external IP addresses. This shows that malware did not replace Explorer.exe, but inject malicious code into legitimate Explorer.exe process. So this technique is less likely to be detected by antivirus. Okay, next I will show you the second command, which is I use the Python 27-python.exe. In C drive. For the third command, I will use the conscan, which is the short form for network scan. The command that we use is Python 27-python.exe. In C drive volatility, the volatility dash master vol.py dash f malware.vmem dash profile equals window xpsp 3x86 conscan, and then enter. So these plugins will search memory for both active and recently closed network connection, which result with our output, and both connection originated from Explorer.exe. The destination port is 8080, which is normal, but actually it is frequently used for command and control communication. This strongly suggests that the affected machine was communicating with remote attacker control server. So why I choose all of these three plugins is because each has their own role. So together they provide strong forensics evidence that malware hijacks explorer.exe.